Shut up and sit down.
Merci.
And I know you're all eager to hear César, but let me introduce the man, at least from what I know from the man. I wanted to do an introduction that is normal, right? We do that in conferences. And so I went to his website, on Wikipedia, to see the publication, try to fit in his shoes. And then I realized that my English vocabulary was not strong enough. I couldn't find superlatives. You know, I could have done something like Chun did. The great man from a great university doing a great job, but you don't have like it, right? You probably don't like the guy. So let me stress what is striking when you look at such a resume. This guy has three words that comes to mind: is excellency, complexity, and curiosity in any domain. He's been to very, very nice place where good science is made. He made that. He made a teamwork. He has been publishing in amazing journals. And this is where good science is published. So if you need translation, the terms are Harvard, MIT, and Toulouse, or Science, Nature, American Economic Review, etc., etc. Not only is he a great researcher, but the scope of his research is amazing. From physics to data visualization, economics, a little bit of politics, and democracy. So this guy is really interested in what shapes the world, what makes human society evolve, grow, and how they're organized. So I cannot speak for him. Let me just tell you that from what I learned in science, is we pile up things. Right? Some people would say that science is made up by people that stand on the shoulder of giants. So we have one giant today. So please welcome César Hidalgo.
Thank you. Thank you. Hello. Well, that's very generous of you, Christophe. So, of course, after that introduction, I have nothing else to do but disappoint you. Hein? Bonjour. Je m'appelle César Hidalgo. Je ne parle pas français. Hein? But I'm willing to learn, and I'm going to be moving to Toulouse this summer. So actually I'm here this week, to try to do kind of like some of the things that you need to do before you move into a city. Find a home, find a school for my daughter, and I started to get to know how life in the old continent might be like, and in particularly in this, beautiful city. So what I'm going to do today is I'm not going to tell you about all of my work. I'm going to tell you about a very narrow yet, prolific part of it, which has been the creation of data visualization and distribution platforms. On the surface, this work looks a lot like data visualization work, but as you dig into it, you're going to realize that a lot of the complexity that goes into the creation of this type of work is not so much the visualization of data, but actually the creation of the platforms that allow you to visualize any cut, or section of a data set. And that's where a lot of the complexity is going to be. So what I'm going to do is I'm going to walk you through many examples of work that we've done to distribute large volumes of data in data visualization platforms. I'm going to show you a little bit of like where we are right now in terms of like the boundaries that we're exploring on new features and technologies that we're doing. And after that, I'm going to talk a little bit about how we build this, because these are projects that are very complex and require teams These are projects that I don't do by myself at all, but I do in the context of creating teams that have very particular expertise and dynamics. And maybe that's also an important lesson for people working on this space in how to create, those teams and which type of skills, you need to create the data visualizations that you want. So from an engineering perspective, what we try to solve, it's a problem that in principle is very simple, but in practice, of course, it requires a lot of hard work. And this is the problem that many organizations have. Most of our clients, this is something that we have professionalized, so we have clients now, are large organizations, whether on the public sector or on the private sector, and they want informed decisions using data. Okay? But the problem is because these organizations are large, they always face the problem that data is distributed in many different places, and merging, matching, and analyzing data that comes from multiple streams is very costly. Okay? So just as a way to sort of like illustrate that problem, let's focus on the case of governments. Okay? And in the case of governments, you have by definition a structure that is very, very, very fragmented. Okay? So they would have multiple ministers, these ministers have multiple departments, the departments have different units, and each one of those units and departments has to recollect or gather data, and they do it with different protocols, with different standards. I don't know if you work with government, but people change all the time, they're changing jobs and units and departments. So just the problem of integrating data is very hard, because let's say if you're interested in trade data, that's going to be in the customs authority. But if you want health data, well, hospitals have some of that data, or insurance providers might have some of that other data. Now, if you want transportation data, there are local transportation authorities, there are regional transportation authorities, and so forth. So putting all of that data together is already a challenge. Once you put all of that data together, then you have another challenge, which is, well, different people are not going to want all the data. They want specific parts of it. So can you create distribution systems that allow users to get the data that they need, the exact cuts that they want, but not only the cuts, but also merge versions of that data. That I'm going to call the distribution challenge. Now, if you're able to do that, then you face something that might be a little bit more entertaining, which is the analytical challenge. Well, can you then now provide people tools that allows them not just to have access to those cuts of data, but to start understanding what that data describes. Tools that allow them to see that data in different ways, through statistical tools, through visualization tools, and so forth. And if all of that helps you come up with some sort of decision-making criteria, you're going to be able to get to the automation challenge. Can you transform now a data signal into an action, because you've been able to solve all of these problems of creating, distributing, and analyzing data to the point in which it becomes repetitive, and therefore, you can think about automation. Okay? So when it comes to public data, which is a place that I've worked a lot, the state of the art, unfortunately, during the last decade was filled with good intentions. Okay? So let's look at how usually official open data sites look like. So if you go to Argentina and you look at their open data site, well, you're going to find, it's a website that you can search for certain type of, data by entering a keyword. But what you're going to get is a little file with some numbers, not very impressive. This is something that you kind of use as a decision support system. So you say, well, but that's Argentina, So then you say, well, let's try the United States. And you go to the United States, you search, let's say, for income data, and you get a very similar experience. You get, a search result type of page, that's going to link you to a data set. You download the data set, you get a few numbers in Excel spreadsheet. That's not that great. And then you say, well, then maybe let's go to Switzerland. Maybe the Swiss can figure it out. And you go to Switzerland and you search for their open data site. You search for data for the city of Zurich. You find value added by industry. You say, this might be interesting. But you open the data and what you get is a similar experience. Okay? You get a jambalaya of numbers. This is not a decision-making tool. Okay? This is something that is distributing a few numbers, so this is not great. So what I'm going to say is that when it comes to our challenges, we have failed. We have failed to integrate the data, distribute the data, analyze it, or automate our decisions. These are tools that are very far from even achieving the first of those goals, because the data that are distributed is not integrated. All of these data sets are floating separately on these websites. And one of the reasons why maybe we failed is because we had the wrong design paradigm. So people were thinking of data as files, and what they did is created tools that allow people to access those files. okay? So you go to a website, you search for something, and then, it has a lot of pages that describe each one of the files that you can download, and that's how you access the data. But if you think about it, when you're a scientist, you don't think of data as files. Like the fact that a number lives inside a table or a spreadsheet is something that you use for practical convenience, but it's not why you want the number. The reasons why you want data is because you want to get a better understanding of the world, so you can make better decisions about it, or you can, have at least a better description. So in reality, data is not something that lives inside a file, but it's an element of a story. So what we do, is think differently, and maybe one way to integrate data is to create tools that help us transform data into stories. Why? Because if we're able to transform data into stories, we're going to have created tools that naturally integrate the data. Okay? When you write a story, when you write a paper, when you write a book, that uses a lot of data, these different sources get merged into the narrative. Okay? So maybe if we're able to create these narrative structures, we're going to be able to force us to create tools in which this data is going to come together. So if we change our design paradigm, we're going to have to change our architecture. So instead of having all of the data basically pushed into the front end, into these pages where we download the data, what we're going to do is we're going to push the data into the back end, and we're going to extract, the entities and variables associated with it. So entity, in this, paradigm, what we're going to use it for is to describe, something that is kind of quite general. So for example, there's some entities that are type geography. France is a geography entity, but Toulouse is a geography entity, or Haute-Garonne is also, a geography entity, okay? So it's kind of like an abstraction that has a certain type that is going to be expressed in multiple data sets. So you're going to have data about these geographic entities, sometimes in the Ministry of Education, sometimes in the Ministry of Health, sometimes, in the police department, and basically those things that describe the entity are going to be the variables. So you're going to extract the entities, you're going to find all of the variables that describe those entities, and then you're going to build integrated stories that describe each one of those entities using data from all of the variables. And when you do that, you're going to get a couple of things. The first one, which is very important for us, is you're going to help search engine optimize the data. And this is really important because data, it's very much, part of what people would call the dark web. And if it's not the dark web, it's close to it, in that it's really hard to index it, because Google has no way of knowing, when you have a spreadsheet, what does cell C5 means, okay? Like all of the search engine tools are very eager to understand web pages through text, so they need sentences that have semantic meaning so that they can understand, what data they have. So by transforming data into stories, you express this data in stories for all of these entities. So for example, in Data USA, which I'm going to show later, you have pages for each of the census designated places in the US, which are thousands of places, and they include sentences such as the median household income of Tulsa, Oklahoma is, and they give you the number. And by having those sentences, you're helping the search engines discover the data that you have. Okay? So this allows you to increase the surface area of this data for search, and allows people to actually find the data that they're looking for. Because when the data is buried into files, basically it's not accessible to search. The other thing that it allows you to do, and which is something that we're moving into right now, is that by putting this data together, you facilitate, future machine learning work. So if anybody here has trained a machine learning model, something as simple as a regression or something as complicated as a neural network, you all know that 99% of the work is cleaning and organizing the data. Okay, running the model is kind of like the fun part that happens at the end. Well, you have to tune it, but honestly, the part of cleaning and organizing the data is a big part of the labor that you need to do to create predictive models. So if you're able to put all of this data together and you have it organized, then building tools that make use of that data becomes much easier, because now you can assume that you have an API endpoint that gives you the data that you need. If you need to train the model again, you just run it, it pings that API endpoint, the fresh data comes in, you train it, you make the prediction, and basically you can move on into more interesting things other than cleaning data. So the way that I think about it is a little bit in the analogy of previous industrial revolutions. So if you think about industrial revolutions, they usually have some sort of duality between like some sort of fuel or source of energy and some sort of engine, okay? So in the first industrial revolution, you had coal and you have steam engines, okay? And then you kept on moving. Eventually, you had electricity and you had electric motors and, like light bulbs and so forth. And in this fourth industrial revolution, I do think that there's a duality between data and AI. AI being the engine, but the engine not being able to run if it doesn't have the data that you need to feed it. Yeah? So there is the need to create quote-unquote power plants, like places that concentrate data that you can use to train these models. Of course, this is something that big companies like Google and Facebook have. They have lots of data that they can use to train their models, but for public data, we don't yet have very good public resources that we can use to start training models for things that we might care about, like unemployment or the spread of a disease like we see now in China. So let's look now at some example of these tools. So if you go to Google and you search for the exports of France or Canada, United States, Cameroon, whatever country, one of the first links that you're going to find is a link to the OEC. This is the Observatory of Economic Complexity, and this is a tool that visualizes all of the world's international trade data. It has a huge surface area because it shows data for all countries and products and so forth, and it makes millions of visualizations. But this tool is not that old. Actually, it's a tool that we created in the year 2011, and it's the one that got us started into this business of creating platforms to integrate, distribute, and visualize, large volumes of data. And since then, we started to create tools that were more ambitious, that integrated more data, and that, expressed it in more diverse ways. So on 2013, we created, Dataviz. Dataviz was a tool that we created together with the state of Minas Gerais in Brazil. It visualized data for all of Brazil. Brazil is, in a data sense, larger than the world because the world has 200 countries, but Brazil has 5,000 municipalities. Okay? And here we had like individual level data for all of the formal sector economy of Brazil. So we could look at employment, we could look at industries, we could look at labor mobility and so forth. Then on 2014, we created Pantheon. This is a tool that is a little bit different because in this case, we have also generated the data. Instead of looking at exports, here we look at exports of culture. So if you go to the OEC and you look at Brazil, you would see that Brazil exports aircraft and coffee and iron ore. But if you go to Pantheon, you would see that they export soccer players, musicians, architects, and so forth. Because we gathered data in the latest version from the 70,000 most popular biographies in Wikipedia, and we use that to create patterns of cultural production throughout history. On 2016, we created Data USA. Data USA, it's now a very popular site. It's the #1 tool to visualize US public data. It's a tool that makes available data not only about the US economy, but also about insurance, about health, about freight transportation, about housing and living conditions, about drug addiction deaths, you name it. There's more than 1,400 variables in Data USA. In 2019, we created a tool for the government of Estonia. Okay, this is the official trade statistics site for the government of Estonia. This is a simple, tool compared to the other ones, but it was also one that we were able to deliver only in a matter of 2 or 3 months. And if you compare with the OEC, which is a tool that would be analogous in its capacities to this one, which took 2 years to make, it shows also a little bit of the learning curve that we've developed as we created, teams and tools that allow us to do that. And we created tools, in the context of, Africa, Korea, Chile, and other countries. And we also created tools for private sector companies that leverage the same, capabilities. And this is something interesting from an innovation perspective, because it shows like a path from, public open source work to the creation, of private tools. Here I cannot show you the details because this is real company data. Okay, that's why it's so small. But when you are in the business of trying to create some of these tools, it's very hard to get started, with companies themselves because companies want something that is proven and working. Yeah? But by starting with public data as we did, you're able to develop the technology, show that it works, and then you can port that technology to other application domains. In this case, it's a consumer product company, so you can see, how the products are changing over time. You can make predictions of future sales. You can see how those sales vary by demographics and by, locations and so forth. Now, do these ideas work? Do we actually get to search engine optimize the data when we transform it into story? So here you have the traffic to the OEC from when we launched in 2011 until somewhere in 2018. And you see that traffic goes up over time. It goes down during the summer vacation and it goes down during Christmas because not so many people are searching, for trade data in August or, on December 25th. But in general, it tells us that, if traffic is going up, it's because basically this has become like a work tool for many people. And we have actually many bankers, many people working on development agencies, many people working, on export promotion agencies that use the OEC, on a regular basis to access that data. Is this that just we got lucky when we built our platform? Or is this something that we could reproduce given what we've discovered as a way to distribute data? So here we have the traffic to Data USA. So when we launched Data USA, it had a huge peak of traffic because there were like big news about it. So it was on the New York Times, it was the most shared news of the Atlantic, there were many blogs written about it and tweets and so forth, but that traffic goes up and down. And if you ever kind of like launch a product, you're gonna see that you have kind of like a blip at the beginning, people care about what's new, so you get attention because it's new, but then that attention goes down. And that attention also is not the best quality of attention. It's basically, people being alerted about something or bumping into something in social media and so forth. But as time goes by, search engine optimization takes over, and now we have more traffic in Data USA than what we had in the beginning, and we have better traffic because these are not people that bump into an ad in, like Facebook or that bump into an article in the New York Times. These are people that actually are searching for that data and they're finding a solution when you get this result. And this is also affecting the way that governments think about like creating like new open data sites. On 2017, I know that this is 3 years ago, but this is how the US Census site looked like. This is, a plan that some people at the census shared with us of the new site that they're trying to build. It's not out yet and they haven't built it, but it looks like a copy of Data USA, which tells us, that actually they're getting inspired by these ideas in the way that they make their data available. So with that, we help, win the integration challenge. When you go to Data USA or when you go to any of these sites, there are many sources of data that are integrated naturally into these narratives. As you're scrolling through those pages, you don't know where a data source ends and the other one begins, okay? They're all integrated in the same place, because honestly, you don't care if the data is coming from this ministry or from that department, you care what the data is about. So we basically flip the way in which governments deliver the data. The way that they do it right now usually is based on who collected it, and we, instead of delivering the data based on who collected it, we deliver the data based on which entity is it describing, whether it is a city, an industry, an occupation, a university, and so forth. But when it comes to the distribution challenge, this doesn't, completely solve it because, well, the data gets trapped into these visualizations or these narratives, and maybe the user wants to have something that is a little bit more low level. So what we did in 2017 is we released a new feature in Data USA, which is the data integration card. And the way that it works is that anywhere on Data USA you can go, and when you find a data set, if you want to merge it with other ones, you only need to add it to the card, okay? And what the card is going to do is going to find if the data sets that you have in the card and the one that you're adding match, and if they match, it's going to merge them, and then it's going to start creating like a merge file with all of the data that you want. So here, this user is now looking at the profile for Cook County, Illinois. He's going to add, some data on health and safety, for example, Medicare enrollment, and heart and disease, by county. And then when it goes, to the card, all of that data has been merged and is ready to download. So now any user can go, browse through the site, find the data that they want, they add it to the card, and that's how you can solve the distribution challenge. Now, a very, inexperienced user without the need of programming can merge multiple data sets, in a very simple interface with very few clicks. And that's also something that you want to always be thinking about, when you're building these platforms, It's not just about like the visualization they're going to be showing, but also that visualization or that page or that narrative is going to have certain follow-up questions that you want to try as much as possible to help the user discover and make sure that they're not far away, okay, in terms of navigation, that they can get to those relatively quickly. Now for the analytics challenge, that's a much more difficult one, but we have been doing a lot of things, to help support that. This is not very bright, I apologize for that, but this is one of the new features that we're creating in the new version of the OEC. So the Observatory of Economic Complexity has gone through 3 versions. We're doing a 4th one that we're going to release hopefully by the end of February, maybe during March. And one of the new features that we have is that we're running prediction models directly on the data, and we're providing full control over to the users to those prediction models. So here you have the exports of France on wine. The red dots show you the data. The line is the prediction of the model. Here I can look at France exports of wine to China, and then I can add, for example, also the United States. I can ask to drill down instead of aggregating, and I can create those predictive models on the fly with the data. So if you look about it, here we have country, product, destination. So if you consider each one of these unique combinations is 200 by 200 by 1,000, so there are millions of possible models that you are unleashing by having kind of like these very expressive, pipelines and having the predictive tools running right on top. In Dataviz, we also have like some other generated tools. One of them is this Viz Builder. This also runs, and as you're gonna look more and more into this, what is really cool about these sites, and why it's really hard to build them is not so much, the front end, even though the front requires a lot of work and there's a lot of stuff that goes there too, is the APIs that we're able to build, okay? Because they're super expressive. So this Builder is a very interesting tool because it looks very simple. It's not that simple to use, but it has a user interface that it was not created by a designer, but it's informed directly from the database schema, okay? Actually from the schema of Tesseract, which is a roll-up server. So what the user here is doing is, like, for example, looking at the population of the US, and you can group it and cut it by all of the dimensions that are going to be available, for that variable. So you have population, you can cut it by state, then you're going to choose, for example, gender, you're going to select female, so you're going to have now, female population of the United States, then you're going to cut it again by race, choose African American, now you have African American, female population of the US, then you cut by industry and you choose, software publishing, and you immediately get data of, females that are African American working on the software publishing industry in the United States. So you can go very deep, into those data cuts, because you have a tool that generates that user interface, programmatically, because the number of options are too big for a designer to be able to deal with it, okay? But beyond that, we also ask the question, well, can we actually, make this even faster? Can we transform this into like a one-click operation? So one of the things that we did with one of my students, is we studied the problem of actually predicting the design choices that people make when they make a visualization. So what we did is we would grab data sets, and we would ask the question, well, if you would have that data set, how would you visualize it? Which columns would you select, or what would you put on the x-axis or the y-axis? Would you make a scatter plot? Would you make a bar chart? All of those type of design choices that we make. So transforming a data set into a visualization required to make a lot of design choices. Unfortunately, there are now tools that encode those visualizations in languages in which those design choices are, expressed. So we grab 1 million data set visualization pairs from Plotly, and then we use those data set visualization pairs, to train, a deep learning model that would allow us to then, predict the design choices that a user would make. So you can think of this as like the Viz Builder, as we've shown before, but with one click. So you would have a data set, and then in one click, it would transform it into a gallery, and that gallery would be sorted based on what people are more likely to do with that data set. Now, people are not always great. People make bad choices, and when you do machine learning, you might be reproducing bad choices that people make. But one thing that is better than people is groups of people. Okay, groups of people usually tend to get better outcomes than single individuals. So when we tested, our visualizations, we find that actually, in this case in which we're trying to figure out which of 3 possible visualizations you're making, VisML, which is our algorithm, was better than single individuals, and it was equivalent to the consensus of a group of individuals. Okay, so we were able to predict, the visualization choices that a person would make using this machine learning. We also show in a related paper, that we were also able to predict what people call the effectiveness of visualization. When you have a visualization, people ask themselves, well, when people read this information, do they make mistakes? Do they, like a pie chart, for instance, is not a very effective visualization. And those effectiveness criteria have been coded, and you can also, create machine learning models that then, given your design choices, can tell you what's the expected effectiveness. Another analytical tool, is this tool. Which country is this? Can you guys recognize the country in the picture? It's Argentina, correctly. That big mountain is Buenos Aires, because this is a map of the population of Argentina being into 1 kilometer hexagons. And this is a tool that we were creating there with the federal government, because Argentina is very interested in trying to improve the public investment. So this is the population of Argentina, and this is the population of hospitals in Argentina. So each one of these bars now doesn't represent people, but represent hospitals with their capacity and complexity. And based on that, we can basically look at where hospitals are and where people are, and we can see which are the people that don't have access to hospitals because either the hospitals are too far, or they're too small, or they're sharing the hospitals with too many other people. And with that, we have been creating algorithms to now start predicting location for future hospitals or places where hospitals could be improving, as a way to minimize the number of people that don't have access. This is a very interesting problem because you can define different type of objective functions. You can try to say, hey, we want the people that are worse off to not be worse off, but that might mean building a hospital in a very remote part where nobody has access to them. Or maybe you want to maximize the number of people in which you have an impact, and that might involve building a hospital in a place where people are not that bad off, but there's a lot of people, so the impact is distributed in that large population. So here you have a different, for example, objective function. This one, you see, is not so much in Buenos Aires. This one looks more at people, that are actually in a bad situation. The other one looks more at like the number of people, as a way to make that consideration. And to conclude, before we go into discussing the technologies and the teams, is I wanted to do like a few words on how we build these tools. Okay? So what we're doing now is we got to a point in which we're not in the need to quote unquote build the tools ourselves, because we build tools to build the tools. Okay? So when you create a site like Data USA, let's say we wanted to create like something like Data Europe or Data Russia or any of these data platforms, like what we provide now to clients, is a CMS, a tool, that allows you also to like explore the data and generate API endpoints, so that you can create, like this experience that the end user is gonna see. Okay? So we've gone to a point, in which now we're creating tools to be able to make the platforms, and we're hoping that that's gonna do 2 things. One, of course, it speeds up our ability to create these platforms, but 2, it allows us to include, other people into the creation of these platforms, because we don't need people that are experts in JavaScript and React and all of those things to create content, which is something that is very hard. We can have people that are, more on the content side of things, like economists or political scientists, to help create that content. So we've been creating, these CMS type tools, And this is just to give you an idea of like a little bit of like the stack we have. This is a company that we started, like 7 years ago that is the one that has been creating a lot of these tools, and basically, like what you've seen so far is always, things seen from this perspective. So I showed you a lot of like these profiles, okay, where the data gets integrated. Those profiles get edited by the CMS, okay. I showed you the piece builder, I showed you the card. We're working also on making a front end for statistical libraries, so you can run multivariate models and all of that type of stuff, But all of these things, that they live in a React library that is called Canon, that we created, and they make visualizations using D3+, which is a library that we built on top of D3 that makes templates of visualizations. Is run by this thing called Tesseract, which is a roll-up cube server that what it does is allows you to create what we call expressive APIs. And this is something that I find is very important in this space, because a lot of times people would throw data into a database, and they would say, oh yes, and we have an API, but the API has like very few entities or very few ways to cut the data, okay? So if you want to create a tool that allows you to visualize the data or analyze the data, you're going to need to have a lot of ways of cutting the data, and that can become unwieldy very quickly. Just to give you an example, even in something as simple as the OEC, in the first version of the OEC, we only had trade data, and trade data has year, country, product, destination, and a value, okay? But that table can be very, 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 very big, So if you want to create a tool that does that, you don't want to be querying that table every time, because it's a big table, you're going to have either a big payload or you're going to have to be aggregating lots of data. So what do? Well, in the old days, what you would do is what you would call sharding. Okay? So then you create another table, let's say, that is just country, product, and year, but adds overall of destinations. Okay? So it's saying, how much France exported in wine, but you don't have like Germany and Greece and the United States as separate rows. You just put, and then you have another one that is just how much France did export this year. Okay? Because you are aggregating. So you have to create a lot of auxiliary tables. So if you have a few dimensions with hierarchies, well, that's easy. You can do an ingestion pipeline that surely creates, 32, 64 tables, whatever you need to have all of the things. But when you have thousands of variables and when you have many hierarchies, and some of these hierarchies might be overlapping or not, keeping track of all of that is really hard. And what Tesseract does is allows you to create all of those aggregations on the fly. Okay? So you load the data, you define a schema, but then you're able to create these very expressive APIs. So you say like, give me this data, by year aggregated at the level of the county, or any combination, and it's going to be able to produce an API input that gives you that exact payload, and it does it very quickly. This was not our first attempt to do that. We used to have another tool, that we had built in Ruby that was called Monte. We had to ditch it because it was too slow, and then we built Tesseract, which is built on Rust, which is a language that allows you to do things a little bit faster. Tesseract lives on top of ClickHouse, which is a database that is open source, that is developed by Yandex. And then before that we have Bamboo, which is a set of ingestion pipelines that allow us to standardize and accelerate all of that ingestion process. And on the front end, really everything lives on this kind of React library, which allows us to reuse things that we use in different sites. So if we develop something for the OEC, we can use it in Data USA, and vice versa. And to conclude, I'm just going to show you like a little video of DataWheel, which is the company that is now doing this work, to summarize what we have done. And after that, we can have some questions. Thank you.
Today, every process generates data. Every product that is shipped, every sale that is made, every trip that is taken leaves behind drops of data. But even today, most data is frozen, trapped in icebergs that keep our data safe, but also far from those who need it to inform decisions. For more than 7 years, we have been creating the tools needed to thaw the iceberg. Our research has resulted in award-winning data distribution projects like Data USA, Data Chile, and the OEC. Today, we can provide you the tools to offer high-quality data distribution platforms, from high-gloss front-end solutions to the APIs and ingestion pipelines needed to infuse them with data. Together, these tools result in modular solutions that can be adjusted to your needs. Let's make sure this decade is not like the last one. Let's make sure this decade, your digital transformation is complete. Thaw the iceberg. Put your data to work with Datawheel.
Thank you very much. Happy to take your questions.
Thank you so much, César. So we have time for lots of questions, and I have the mic, so raise your hand.
Thank you very much for a very impressive presentation and for your work. All the platform you show are very impressive. My question is about building confidence in the data. That's something, so the first thing, actually, at least I do when I'm trying to, well, when I'm playing with a new data set, is trying to build confidence that the data set is actually correct. Because data can be sparse, can be biased, can be corrected even. Do you have insight on how you can, be sure that data you got is actually, you can trust them and go on with all your visualization?
So it's a very interactive process. So even in the best cases, like building this tool takes months. So, and as you're building the tool, of course, you're always looking at it and you're always commenting it, and you're seeing the weirdness in the data, and you're seeing the anomalies. So, like, what we find is like two things. On the one hand, in many of the public data tools, we have like an editorial line in which we try to, we not modify the data. Okay, we say this is what the government has. No, and we're showing you what the government has. We're not showing what the government should have. But on the other hand, sometimes there are like things that like look like clear, like errors, for example, that that big gaps in values that probably there were changes of classifications. So then when we see that, we get into that, and then we make design decisions of which sections we might want to like show or emphasize or use in the models, because we start understanding those problems. But I do think that visualization, one of the best things that it's able to do is to find anomalies in data. Because with the statistical models, when you're looking at little stars and tables, you don't know how those lines look, and visual inspection usually can show things that are very conspicuous. So it's a very iterative process, and one of the things that these tools are good at is to help people find those mistakes, and then realize maybe where they come from.
Another question here.
Yeah, thank you very much. I'm wondering how the semantic things can help here, because the entity you have described may be part of DBpedia or Libraincor, stuff like that. And would describing them help with semantic things, could help to create more interoperability? Or I'm really wondering if it could help here.
No, it's interesting because like the problem of merging data is always very complicated. When you move across different domains. A lot of the data we use comes in classifications. A lot of times also we do create like semantic descriptions of those classifications to simplify the names. For instance, when you look at trade data, names sometimes can be like 25 words, because like countries don't export cars, they export unladen passenger vehicles of less than 2 tons, with a motor of less than 500 cc's, and people, of course, are not going to be searching for that. So we do use semantics for that, and we use, in the search, now we use, we have trained some deep learning algorithms, so if you search for tequila that doesn't exist, you get spirits, okay? So that we can do those connections, and that's a place that we're playing a lot right now, because we do find that a lot of connections could be made by using like those type of semantic linkages. So we're using it in search, we're using it also a little bit on research, but I think eventually it could be used also to help merge data sets. So one of the things that we are doing also in the context of trade data is to see if we can use semantic ideas to create crosswalks, okay? Because some of the problems that this data set have is that there are many different classifications. So like in the 60s, 70s, and 80s, trade data was SITC, Standard International Trade Classification. In 1992, it came to the harmonized system. But then there is HS92, HS96, HSO2, HSO7, HS12. So they keep on changing that system all the time. and countries report on different things, and you need to have those crosswalks, and those crosswalks, sometimes you have to wait for the WTO to come up with one. We don't know how good they are. They don't exist for every pair. So using the semantic description, something you say, well, this product semantically is described similarly to that product in another classification, and therefore we could make that crosswalk. So that's also another application. So I do think that that area of like using semantics to create, crosswalks and merge datasets is an interesting one because it's useful. You're not going to get perfect results, but you're going to get some results, which sometimes is better than nothing. Yeah.
Christophe has a question.
Hi, thank you for your very inspiring presentation. I have a question regarding visual literacy, because you're presenting a lot of data and with different types of presentations, and I'm just wondering how people are really able to understand your data, because you're using, as far as I've seen, maybe 4 or 5 types of data visualization. So I saw some tree maps. I didn't see any parallel coordinates, and maybe that's any other more complex visualization like networks and things like that. And so I'm just wondering, because you have all these presentation tools, you're also collecting a lot of data, and how do you think that all of this will help people to understand the data and to understand these new types of visualization?
So literacy, I think, is important, and sometimes there are heated debates about it. I'm more from the perspective that people learn if they're exposed to things, so you shouldn't hide things because people are not literate. At the same time, the people that are searching for data on the web, like the users of our tools, they tend to be quite educated people. So when we run surveys about the people that use these tools in the OEC, like around 30% of people are people working in some sort of banking, like hedge funds or investment banks or development banks and so forth. There's a lot of people that work also on policy agencies in government. So it's usually people that have relatively high levels and they can understand things. So I do think that on the one hand you have to know your audience, and on the other hand you want to educate them by exposing to things. And there is the opposite problem, which is sometimes, like the 10% of traffic of people that are more influential might be more important than the 90% of traffic of people that are going to complain, and they're just there, for some fortuitous reason. So, you also want to be careful of not err on the side of sometimes making things too simple that you lose the most relevant audience. Because, let's face it, not every user matters the same. Some users, are influential and important and are the ones that you're trying to engage. Some users are people that are just passing by, and you want to try to design for the user that is going to be coming recurrently, the one that's using the tool for work, the one that is actually, building on it. And that user tends to be more sophisticated.
And on that topic, did you record what the people are doing on the platform, so you get some information on what are the main part or the main graphic they are looking at?
So we've used kind of tools like Hotjar and things like that to understand how people are using the platform. What we learned from that is surprisingly a lot of people seem to be reading quite a bit. We thought at the beginning the text honestly was there for search engine optimization, and we thought, okay, people are using this to find the visualizations and then they come and experience the visualizations, but there's a big fraction of our users that are definitely readers in the sense that they go into the paragraph, much more than into the visualization to learn about the data. So we're now putting more effort into making those paragraphs, more explicit, longer, to include more details, because there is a fraction of the population that are not visual readers, they're more, narrative, and we want to make sure that also, the text is not just there to get the hit on Google and bring people to the page, but also, in lieu of the visualization, because some people gravitate towards that. Yeah.
Are there some other questions? Otherwise, I will talk online.
Yeah.
Hi, thank you. Just wondering if you can handle some unstructured data there, because from the beginning you are presenting us CSV files, or I don't know what kind of files, but if you are looking at web pages, usually you don't have this kind of data. So do you have something for that or not?
Yeah, so we work a lot with structured data, and when we don't have structured data, we try to structure it. So for example, like Pantheon, is a structured data set that is built by using NLP on the Wikipedia pages, okay? So the Wikipedia pages are in principle unstructured data, but they contain information about, like where people has lived or what occupation they had and so forth. And we use NLP to extract that, but then we structure it, and we include it into the platform. So usually like this, the type of platform that we do, are built on the assumption that the data was structured at some point. That doesn't mean that we don't work with unstructured data, but that we find ways to structure it to show the information that we want, or that we need.
Thinking about Pantheon, you structure it with NLP. Would you be able to use semantic frameworks where the user could decide how they want to structure? For example, the biographies to look at some particular aspect of it?
Not at the moment. Like even the script that extracts the data, it runs for a few days, and it makes so many API requests that you have to kind of like run it with a lot of fail safes and stuff like that, because it many times the API request simply doesn't respond or times out or things like that. So you wouldn't allow the user to like run those 70,000 biographies on the fly, on demand. That you couldn't, you cannot do. But I guess maybe in a future in which the web and APIs are faster and limitless, you might have ways to be more flexible.
Who's first?
Yes, hello, thank you. You showed us a lot of data visualization regarding strategic decision. I would like to have your point of view on day-to-day operations and how do you use data visualization in that purpose. And second question is regarding ANITI. What will your role be in that matter? For me, ANITI is about AI. You talk a lot about data visualization, not AI.
Yeah. Okay, good. So the operational role, I think, of course, depends not so much on the tool, but a lot on the user. When we build tools for companies, the use cases tend to be very clear because they come to us, with use cases that are quite clear. So, for example, when we build a tool for a consumer product company, in that case, it's a big company in a very mature market. So what they're interested is, on pushing products and staying ahead of trends, and hence what they were interested is on trying to understand, like the success of the new products that they launched, because they launched hundreds of products every quarter. They were interested also on understanding how the products match demographics, because it was a cosmetics company. So cosmetics are very dependent on demographics, right? People with different skin colors demand different cosmetics and so forth. And demographics, as they shift, they need to make sure that they have the right supply and distribution to all of those places. So they have that type of decisions. In another company that was in pharma, we're building a tool, and in that case, what they're interested in is that they produce a lot of screens, and those screens that are produced by the research teams, they need to be shared, with other research units. And the way that is done right now is they grab that data, they have some, like Python notebook type of thing, they run it through that, they take some screenshots, they create some PowerPoints, they email those PowerPoints, and these are big, multi-billion-dollar companies, but you'll be surprised how many companies still run on PowerPoint and Excel, and basically what they want is to have something which every time a screen comes out, they put it in, the reports get built, they send the link, and everybody has access to like a nice, well-done report, and then when they improve the report, all of the future reports get improved because, this doesn't have to get done. Another case is that is similar in terms of the application, but not similar in terms of the domain, is a mining company in which they also have, reporting, but not in the context of, screens, but in the context of safety. So in mining, I don't know if you guys are familiar, but they have like what you're trying to minimize is not like deaths at the mine. Like what you're trying to minimize is a pyramid in which deaths at the mine are the last event, and then you have events with different type of risk. Because if you concentrate on that event, you don't change it. So you're concentrating on the quasi-events and the events that are like low impact and high energy and all of that. Because if you minimize these type of events, then you minimize those type of events, okay? Because they tend to be subsets of each other. And they have, you know, like a set of protocols and procedures, and they also have to report that because of regulation, and they're using now our tools, you know, to do that type of reporting. So this type of decision making or support tends to be very specific to the vertical, and not even to the company, but to the unit within the company that you're going to be working with, whether it's a strategy or safety or research. At ANITI, I'm going to be working on things that are more related to AI. You know, so this was an invitation by Christophe to, you know, a Dataviz community. So I thought I was going to focus on the Dataviz work. But I've been doing, you know, working AI in a few domains. You know, some which, you know, I did for a while, some which are a little bit newer. So, for example, one thing that I did do a lot during the last decade is to use first, you know, crowdsourced data collection, and then artificial intelligence, you know, to understand how people perceive urban environments, okay? So Toulouse is a city, for instance, that is very attractive. It looks beautiful, it looks safe downtown, you know, it looks lively. It has a lot of attributes that are attributes that you cannot measure, you know, simply with kind of like some sort of survey, because they're perceptual things, they're judgments that we make. When we say that the place looks beautiful, that the place looks lively, that's definitely like a human type of judgment. So we did collect, you know, information about, you know, people's judgments to then create artificial intelligence algorithms, you know, that would allow us to create those map at scale, understand how cities change, and so forth. Now, this is something that we did a lot during the last decade, so it's a little bit older, but it did lead into something that we're doing right now, which I think is kind of cool. So I don't know if any of you have seen a TED Talk that I did like 2 years ago. And if you saw like a TED Talk about augmented democracy, one person, two, like 3, 4, okay, like 5 or 6 people saw the TED Talk. So like 2 years ago, I went to TED in Vancouver, like to the main event, and I presented something that was like a quite bold idea, okay? And my intuition is that, you know, one of the things that makes democracy complicated today is the fact that it's a representative system. Because the fact that we elect representatives generates very bad incentives for the people that are willing to run, you know, in this popularity contest that we call elections, okay? So basically you have to be someone that either has like a huge ego, or that, you know, it's okay with the game of politics, and eventually we end up choosing among pools of people that are self-selected, maybe not to be the best and the brightest of our population, but to be, you know, the most ambitious or the most vicious, you know, of all, you know? So the question is, well, if representative democracy is a problem because we have representatives, do we have technological alternatives that allow us to create different forms of representatives? And what I suggested instead is the idea of augmented democracy, in which we would use AI to give each person a representative that would be an AI agent that you control. So, you know, you have 60 million people, you have 60 million senators. And those senators are AI agents that each person, you know, gets to control and represents them, you know, in a parliament that there's as many representatives as there are people. That sounds like a super weird and crazy idea. Yeah? And I agree that it's weird, it's crazy, and it's scary. Yeah? But luckily enough, you know, what happened, I don't know if you guys saw what happened in Chile a few months ago. Yeah? Because it makes the protests in France look like child's play. You know, so just to kind of like give you an idea of what happened in Chile, just to give you the story, and to build into like, let me just show you like some video about Paraíso. Since I have internet here, you know, so let me show you kind of like some video. So this is like, imagine here like in Esquirol in Toulouse, this is like a commercial street. After every store was turned inside out. So you see, this is, you know, all of the stuff of the store was completely destroyed, and, you know, so there were like lots of riots, and it's still like a very complicated and very politically active situation. And all of this started, you know, at the end of October, and when that happened, together with, you know, my team, we released this platform called Chilecracia, that the first game that it had, it was a game about, you know, giving priorities to people's preference over policy choices. Okay? So I'm going to translate here for you. So for example, here it says, what would you prioritize? Would you prioritize, like making amends and providing support to Native American, or to reform, the Chilean police? And this is not an either or. It's like, like imagine you have a deck of cards. There are 200 things that we want to do, and you're trying to sort them, and everybody gets, to start flipping cards. So let's say that we click on number 1, you get another choice. Do you want to return, Parliament to Santiago? Do you want to have bigger penalties for people that are involved in political corruption? Okay? Let's say you click 2. And what happened is that when we launched this in a politically active context, we were able to collect, almost, 8 million preferences of people. Okay? So tons of people participated, and now, we have data that we can use to create some very primitive versions of these digital twins, because, we can create, based on the data that we collected here, AI agents that can predict how an individual would select over the pairs that they have not seen based on the pairs that they do have seen. So what we're going to be doing is we're going to be exploring these ideas, of creating, digital twins, creating augmented democracy, by using the data that we collected in Chile, using data that we collected also. We released a few of these platforms. There were a group of students at Harvard that came to me, and we created Lebanocracia, and there we also collected, about 300,000, preferences of people. We did it in Georgia, we did it in Colombia. So we're going to be exploring these ideas as well. And that's one thing that I'm doing. Another thing that we're going to be doing, and this is, for example, that could be like a cool other talk. Let me just go into my folders here. I finished a new book that is called How Humans Judge Machines. Okay, and what we're doing in that book, is we are looking at like how people judge machines compared to the way in which they judge humans making the same mistakes. Okay, so it has to download because it's on the Dropbox. So basically what we did is we did more than 100 experiments in which we have a machine making a mistake and we have a human making the same mistake. Okay? And then we ask hundreds of people to evaluate, to judge, like how the machine did, like was it immoral, was it harmful, was it intentional, and the same questions were asked, about humans. And this allowed us to create a very comprehensive, compendium of the way in which, people judge machines. So compared to how they judge humans. So like this book now is, it's going to come out with MIT Press, and it has some kind of like interesting, findings of how people judge machines in the context of different moral dimensions, harm, purity, authority, authority, loyalty, and so forth, and also how they change overall, when you are evaluating situations of humans and machines. So, we have, this is an example of like a machine or a human making an ad that is controversial. These are examples of algorithmic bias. These are examples of like self-driving car accidents. These are examples of machines, desecrating national symbols like flags and things like that. Here, then we have also examples of privacy, label displacement, and so forth. So this is also something that we're going to continue to explore, which is how people perceive and judge, AI compared to how they judge humans, and what are the things that provides us with biases when there's artificial intelligence. So these are a few of the things that we're going to be working on that space. But my hope is that also we're going to get new ideas here, by working with the community of people around here.
I think we have the last question here.
Yeah, sorry, that was a bit of a long answer. Yeah.
Thank you so much for your presentation. My question will try to tie together. So, in your TED talk, you were trying to build some representative to, and my question is, if you're trying to understand how people would decide on any subject, will data visualization will help anyone to make better and informed decision about a particular topic, and more importantly, make hypotheses on the effects of a particular policy or...
Yeah. So this is kind of like what it gets interesting, because what I think is interesting about the intersection between data, democracy and AI is that there's also a lot of sort of questions that are a little bit more normative. So we can think about democracy and what's the objective of a democracy. Is it to represent people as is, and therefore you think a certain way and he thinks a certain way? I should try to build a system in which your way of thinking and his way of thinking are well represented? Or should we make a system in which we try to provide you with information so as you to come up with the right decision, but then what is the right decision and who gets to decide, or what are the criteria that we're going to use to try to push or promote information in that learning context? These are all things that I think we can explore and learn better when we have tools that we can play with. So my objective is not to change democracy for a set of avatars anytime soon, but it's to create tools that we can use to play with these ideas in non-binding contexts. So for example, in a place like Chilecracia, we could release an avatar that you can create, and that now for example we have connected all of those policies with the actions in Congress. So here you have all of the laws in Congress that are being discussed right now, and we can make that type of connection, and then you can see, well, how did the politicians vote, and how would your avatar have voted, and that can all be a game that can stimulate some sort of discussion of this interface, because I do think that there might be a world in which the transition between systems that have more direct forms of participation or more frequent form of participation. A lot of people say, for example, that a problem of democracy is that it's very hard to keep people accountable when their actions are taken day to day, when they get accountable once every 4 years, So like that, there's like a mismatch of scales, And by having, ways in which actually, people can start experimenting with the idea of having more fluid, forms of participation, and we can also test the idea if these fluid forms of participation affect learning, or how we, design them to promote learning from people. I think there's a lot of questions, so that's why at least I like this research problem, is because I know very little about it. So there's a lot to learn, and I think, that's a big set of unknowns, which gives an opportunity for a lot of people to participate, in what can be an exciting area of research. Thank you.
Thank you very much once again, César, for talking about everything.